I'm a pure mathematician, and I work on what's called basic research. This means research which does not have a direct application, but is rather, its main goal is to advance human understanding of mathematics as a whole. Here's the question I often get asked when I say I'm a mathematician, because possibly I don't look like a typical mathematician. Why study math? What's interesting about math? Or isn't everything in math already known? Mathematics is very different from what we teach our kids at school. So it's not about long calculations and formulas. It's about finding patterns, ideas, analogies between things. This is real mathematics. It's perhaps the most abstract of all of science. In fact, one of my recent discoveries had to do with finding connection between two fields which were relatively remote. So one of them is called symplectic dynamics and the other is my field, it's convex geometry, and we found a very tight connection between the two. A connection between one of the main open problems in one field with one of the main problems in the other. And this means that sort of the scientific effort could be joined between these two groups towards solving these problems. This connection that we found, it goes via something which is actually pretty well known. It goes by billiard dynamics. So you all know what a billiard table is. Occasionally we maybe play billiard, but you can also imagine changing the shape of the table and see how it influences the billiard trajectories, the way the ball moves. What is harder maybe to imagine is changing the table to have more dimensions. So 3 dimensions actually you can imagine. You can imagine a room which is covered with mirrors and you shoot a laser beam and it reflects and it makes some kind of trajectory. This is like a billiard trajectory. Or maybe you're playing billiard in space where there's no gravity and you throw a ball and it bounces off the walls and you try to go around some obstacles or maybe you try to get into some hole. What's even harder to imagine is higher dimensional billiard. So what is higher dimensions? We're used to geometry in 2 dimensions and 3 dimensions. But higher dimensional objects are actually, we use them all the time because it just means something with many parameters. The amazing thing is that our geometric intuition from geometry in 2 and 3 dimensions goes through to these higher dimensions. You can actually do geometry in high dimensions, geometric intuition in high dimensions. And this is what I do. This is my field. And with this kind of intuition, you can also study billiard trajectories in higher dimensional objects. And this was what helped us make this connection between the two fields, the connection I mentioned. One of the things that inhibits, I think, women from pursuing a career in mathematics is that they see scientists as these big men in white coats, these inapproachable, maybe geniuses, and sort of a normal person might tell himself, I'm not good enough to do this, and especially women who do not see role models who are women who do this. I'm not a genius, and 99% of my mathematician friends are far from geniuses. We just do this and we work hard, and all you need is really to be enthusiastic, to like what you do, and to come with an open mind. It pushes your boundaries, and I encourage you all to do this, and maybe if you do it, you will also, just like I did, find it extremely fascinating and love it.